I've been doing a VLBA project that's designed to locate the supermassive black holes in nearby galaxies and see if any of them are not at the centers of galaxies where they nominally belong. Somewhat to our surprise and disappointment, nearly all of them sat right in the middle of the galaxy as expected in the traditional picture. But there was one case of a supermassive black hole that was distinctly not in the middle of the galaxy. So we followed that one up. And this particular galaxy is more distant than most galaxies in our sample. It's about 2 billion light years away. And it's much larger and brighter too, because it's the brightest galaxy in a cluster of galaxies. And I think of them as Jabba the Hutt type galaxy because they got that way by eating all of the galaxies that were in their neighborhood. A smaller galaxy that falls toward the center of the cluster tends to get ripped apart tidally by the central cluster galaxy and merges in to become part of a very massive, very large, bloated, extended galaxy. So we followed up using data from the Hubble Space Telescope and from infrared satellites like Spitzer to see if we could look into this big galaxy and see where the radio source is. And it turns out there is indeed another very small galaxy exactly located where the radio source is. And it's not at the center of the big cluster galaxy. This galaxy didn't look like a normal galaxy. It has a lot of debris around it. It is stars or other sources of light, probably some dust absorbing some of that starlight, that looks like it's been scattered around or ripped from the galaxy in the first place. So that the galaxy containing the radio source isn't the normal galaxy at all. We concluded that our fleeing black hole was incapable of attracting that many stars on the way out to make it look like it does now. The other alternative is there was a normal full-size elliptical galaxy somewhere out in the outskirts of this big cluster of galaxies. And only now, after many billions of years, has it finally fallen into the center of the galaxy. And it fell into the center of the cluster on an orbit that took it nearly into the middle of the big galaxy, where the gravitational forces and tidal forces are so great that they tore off all of the stars surrounding the black hole, except those that were very close to the black hole. So now the black hole isn't clothed by a full-blown elliptical galaxy, but has been partly stripped and is now nearly naked. But since it's moving along at a fairly steady rate of speed, it can hold on to stars a lot better than it could have captured stars. So it and stars within a few hundred parsecs are now escaping from the giant galaxy and moving with a speed of about 2,000 kilometers per second. And they will continue to move, completely escaping from the giant galaxy, but probably not from the whole cluster. And it's interesting to think about what happens to a galaxy when most of the stars have been stripped away, but it still has an active supermassive black hole in the middle. And in the long run, what will happen is there won't be any more gas to feed the black hole, and there won't be any more gas and dust to make new stars, so that the galaxy will get dimmer and dimmer as the existing stars age, and the black hole will get dimmer and dimmer because it no longer has material falling onto it to feed it and make it light up. And sometime in the billions of years in the future, we're going to have this nearly naked and completely invisible black hole running around in the cluster of galaxies. This is the first time that that's been seen. So it raises some questions about how often does this happen, and how important might it be in terms of the evolution of galaxies and the evolution of clusters of galaxies.